Everyone, this is Sharier, and today I'll talk about my research project that is deep learning. Well, we already know a little bit about deep learning, and that is deep learning is a subfield of machine learning and is a subset of artificial intelligence. Well, how does this deep learning came? The whole thing of deep learning came. Well, deep learning was inspired by the structure of human brain, and that structure we call it artificial neural network. Let's say we have to use a machine to separate different types of fruits without humans' input of the fruit feature. How can we do it? Well, the answer is simple, using deep learning. But now we need to understand how that whole deep learning thing works. Well, for that, we need to know what neural network is and how it works. So for that, I have an example over here. As you can see, we have three different students and they're writing the digit 9 in their own different styles. But think about this. How does the computer can recognize these different digits? Well, as a human being, we can easily tell and recognize the digits despite of their shape, size, and style. But how does the computer do that? The answer is with the help of deep learning. The computer recognizes these different shapes of the digit 9 using the neural network structure. How that works? This digit 9 has 28 by 28 pixels, and neural networks are trained by these pixels, so in total we can say there are 784 pixels. The neural networks are consistent of different layers, like this. The first layer that you can see over here is the input layer, which is called the core entity of a neural network. And this is where we actually process the information. Like all the information that we have, we store over here at the first one. I mean the information for the digit 9. As there are 784 pixels, so that means the informations are stored into this neuron structure here, which is the first layer of the neural network. And at the same time, on the other hand, you can see the end layer, that is the output layer. And in between, there is a hidden layer that you can see right here. The information is transferred from one layer to another over these connecting channels. The layer that you can see here are the connecting channels. So each of these has a value attached to it and called a weighted channel. All these neurons has their own unique numbers associated with it called bias. And these bias are added to the weighted sum of inputs reaching the neuron, which is then applied to a function known as activation function, that is over here. The result of this activation function determines if the neurons get activated or not. And every activated neuron passes information onto the next layer. Like you can see over here, this is activated. This is passing the information to the next one. And this is activated. It is passing the information to the next one. So like this, the whole neural network structure works. This neural network learns to detect different features of an image using tens or hundreds of hidden layers. It doesn't only consist of this amount of layers. There can be 100 layers. It depends on the structure of the neural network. And this every hidden layer increases complexity of the learned image features. So the question comes, what does deep learning require? Well, the hardest part with deep learning is that it needs a massive amount of data. And the reason is that it needs to train its model with this vast data. The more data we have, the product will be a lot more better as the neural network architectures that learns features directly from the data without the need for manual feature extraction. And this thing can take hours or months to train itself, as it depends on the amount of data and the number of layers in the network. But to make this whole thing smooth, we need a computational power. That is, we cannot use the regular CPU. We need to use GPU. GPU means the graphical processing unit. And these actually rapids the process of the data, which is like thousand of cores more than the CPU, and this GPU is really expensive too. Now the thing is this: where is deep learning applied? Well, in our everyday life we see it. Let's say we are using our phones. It has the facial recognition system. That's why deep learning is used. Supercomputing. Although we don't have it, with us all the time. Supercomputing is a really big thing. So deep learning is applied there. But for self-driving cars, we see that every day nowadays. Tesla, Nissan, they all have it. So deep learning is applied there. Customer care support. We pretty much face these things all the time. So when we talk with the customer support, we feel that we are talking with a real human being. But in real life, we're not talking with a real human being sometimes. It's a part of deep learning. Sometimes these conversations with this bot is so real that it makes us think that we're talking with a real human being. And that is the beauty of deep learning, that it actually makes it so realistic that we sometimes get confused if we are talking with a real human being or not. And then we can see that medical care. Well, deep learning has the possibility to change the medical care industry in the near future. Over here, we can see the deep learning was used. As you can see, the neural networks are used to detect cancer cells and analyze the MRI images to get detailed reports, which is a very big helping hand for doctors. And that's it for my presentation. And deep learning is a really big thing, and I cannot wait to see what the future holds for to show us how deep learning is going to change our everyday life. Thank you. Thanks for your time.